So the side splitter theorem, or you might hear it called the triangle proportionality theorem, tells us that if a triangle has a line drawn through it, constructed through it, that's parallel to one of the other sides, right here, then the two sides that were intersected by the line, this one and this one, are divided up proportionally. So we have a couple of things that we can know from this. First one that you should be familiar with already is that we're going to have proportional triangles. So we have, over here, we have this small triangle, which is going to be similar to this larger triangle. You should have already proven that in class. If the two lines are parallel, we have corresponding angles, and then they share the vertex at C, so we know that they're similar. But there are some other proportions that exist. So we have some hole-to-hole proportions we can set up. We'll grab a different color to point these out. We have this side to the whole side, which can be compared to this side of the little triangle to the whole side of the big triangle. And we can compare the whole bottom to the whole bottom. We have a part-to-part relationship. So we can look at this part here is proportional to this part. This part is proportional to this part. We can also do part to whole. And I know it's getting a little muddy here. This is the last one. We'll go through more individual examples in a minute. We can do this part to this whole and this part to this whole. So let's look at some examples with some numbers in algebra. So in this example here, we're comparing one whole side of the small triangle, this right here, to the whole side of the large triangle. And I can split that up to make it a little bit easier to see. We have 6 and x compared to 14 and 21. So this should be pretty easy for us to solve. We have 6 over 14 is equal to x over 21. This reduces down to 3/7. So I know that this has to reduce down to 3/7. 21 is 3 times 7, so this must be 3 times 3, which will give us x equals 9. You could also use cross multiplication here if you wanted. Get x equals 9. So in this one, we have a little bit different relationship. We're going from part to part. Here I'm going to take just this segment CD and compare it to DA. This segment CE, compare it to EB down here. I'm taking the whole side of the larger triangle and splitting it up into its parts. Instead of comparing triangle to triangle, we're just going to compare parts of the big triangle to other parts of the big triangle. So I'm going to set up the proportion in two different ways. You can solve it either way. You can do 8 over x plus 2 and set that equal to 12 over 18. We can also set it up going across the triangle. We could do 8 over 12 is equal to x plus 2 over 18. It doesn't matter. Either one will work. We could also add up the two sides. So we could take these two and add them together and get x plus 10, and we could also add these two up and get 30, and then do 8 over x plus 10 is equal to 12 over 30. I'm not going to solve that right here because I don't think it's necessary to go through that. We can just solve it with one of those two. So I'm going to reduce this fraction right here. 8 over 12 is the same thing as 2/3. And I know that I'm going to have to make this equal to 2/3 as well. So this must be 6 times 2. Erase that. should be 6 times 2. So I know that x plus 2 is going to be equal to 12, which means that x is 10. In this one, it's set up a little bit differently. This is kind of the odd man out here. It's a little bit harder to maybe wrap your head around. This one's going to be a part of the large side to the whole large side, and a part, and we'll have to use the whole over there. So I'm going to set this up. First off, figure out that the whole side over here is 28, and then I have y over 21 is equal to, I need to use this corresponding part, 20 to 28. So then I can reduce. I know that this is 7 times 3, so we must have 5 times 3 over here. So y equals 15. And for this last one, I just want to do a quick demonstration of one where there's 2 algebraic expressions. It seems to make most sense to use a part-to-part, part here, here. So let's set that up. We're going to do, again, you can set this up different ways if you want. That's a 2. And then the only way I could solve this is by using cross multiplication, or I guess you could do guess and check, but I'm going to do cross multiplication. So in this case, x equals 14, and then I might be asked in a problem to plug that back in, which means that this side length would really be 14 plus 2, or 16, and this side down here would be 14 plus 10, which would be 24. So then I could solve for the whole side lengths if I wanted as well. So last but not least, just reminding you to summarize what we have here. There's a couple of proportions you should be writing down. Make sure you come in with questions that you want to ask me. Throw them up on the chalkboard if you want me to clarify something, and get ready to be doing some practice based on these problems when you get to class.